Hey guys, today we're going to be talking about how to use logarithms to be able to solve for that missing exponent. So yesterday we solved some where the base was missing, where the value was missing. Well, we're finally going to learn how to solve for when the exponent is missing. And what we need to know is how to communicate with our calculator, because our calculator only works in base 10. Okay, so log base 10 is what our calculator thinks of whenever we type in log. So whenever you look at your calculator, we have a button right here, right beside the 7. That is our log button, right there. That's our log button. Now, whenever you click that log button, you'll notice that there isn't a base there attached to it. That's because your calculator assumes it's base 10. It's just base 10. So log base 10 equals just log of that value, okay? So we need to be able to convert our complex logarithm into base 10 so we can plug that into our calculator, all right? So here's how this works. So we're going to go, we take our log and our base and our value like this, and if we're plugging into our calculator to find our missing exponent, our base goes on bottom and our value goes on top. So it goes like this. We go log base 10 of my value, log base 10 of my base, and we just divide each other. So like, for instance, if I have a base of 4 and a value of 8, we're going to go log of 8 divided by log of 4. And it's going to work out just like that. We're going to go log of 8 divided by log of 4, and it's going to give me my answer. Let's try that for ourselves real quick. Okay, we can pull up, clear this out. We can pull up we can go log of 8. What was it? It was log of 8 divided by log of 4. So we go log of 8. Don't forget to close your parentheses. Log of 8. So we go log of 8 divided by log of 4. Just like that. So log of 8 divided by log of 4. There's our fraction. We hit enter, and we get our answer of 1.5. So just like that, we created our 1.5 is what it's equal to. Okay, so for your work today, obviously most of your work is going to be on your calculator. But what I want you to focus on is still write out what you're putting into the calculator. That way I can see it. And we need to make sure that we also focus on rounding our answers to 3 decimal places. So we're going to get some practice doing that together today. So first off, let's look at our first one, log base 3 of 15. So what we're going to plug into our calculator is I'm going to go log of 15 over log of 3. And that's going to convert it to our answer of base 10, and we're going to get our answer. So we can pull up our calculator, and I can go log of 15 divided by log of 3. We get our answer of 2.4649. Now, I want you to notice a couple things. So our number here is 2.4649, 2.4649, but we need to round it to 3 decimal places. So if this is 5 or above, we're going to round up the number below. If it's 4 or below, that number is just going to stay the same. So this one is, our answer is going to round to be 2.465. And there is our answer for this first one. Okay. Our next one, let's scroll down a little bit so we can see it. So our next one, remember, we rewrite it. We're just going to go log of 5 over log of 12. We can work this out. We can pull up our calculator. We're going to go log 5 divided by log 12. So pull that up. We're going to go log 5 divided by log 12. Don't forget your parentheses, and equals 0.64 And that 6 right there is going to tell me that we're going to round that 7 up to an 8. So it's going to be 0.6478. 0.6478. All right, our next one. We've got some decimals here. That's going to be our log of our value on top. So log of 4 on top over log of 0.4 on bottom. Once again, grab our calculator. We're going to go log of 4 divided by log of 0.4. We get our answer of negative 1.51. And once again, that 9 is going to tell me that that 2 is going to round up. So it's going to be negative 1.513. So there we go. It's going to be negative 1.513 as our answer. A negative p is okay. All right? A negative power is okay. It's when our base for our value is negative that we have a problem. But a negative power, that's okay. Remember, a negative just makes a fractional a fraction. Okay, next up, we have log of base 2 of negative 5. So we're going to write log of negative 5 over log of 2. And if we plug this into our calculator, it would tell us that we have an error because this is not possible. And it is not possible because we cannot have a negative base or a negative value. So this is not possible. If either one of these are negative, whenever you plug it in, it will not work. Okay? Your answer can be negative, but those two we plug in cannot be. All right, let's dive in here and let's solve for x for each one of these. So for number 5, you'll notice what we are doing here is this. We have this equals x. And so we're just going to plug this into our calculator. We're going to work it out. And we're going to write out what our calculation is. And it's just going to equal x. So on this one, we have a value of 64, a base of 2. So our answer is going to work out like this. We're going to have log of 64 over log of 2. And that's going to equal my x value. And so we can grab our calculator and we can go log of 64, log of 64, come on. Sometimes it does this, freezes up on us, you know. Wish it wouldn't. Okay. Anyways, we plug that into your calculator, we get log base 64 divided by log 2. You've seen it before, we've done it before. And so log of 64 divided by log of 2 equals 6. And we got our answer of x equals 6. Okay? We could also think about this, remember that's 2 to the x equals 64. And you can see 2 to the 6th power does actually equal 64. That one actually works out. Okay, now let's try this one. Let's take this and let's calculate our logs for this one. Let's go log of our value, which is 32, over log of my base, which is 1/2. Plug that into my calculator and we get negative 5. So we get an answer of x equals negative 5. Okay, we're just putting our value on top, our base on the bottom. Okay, hopefully you can see how we plug this into our calculator. Let's move on to the next one. This one, you'll notice we're missing a base. So there's two things that we can do here. We can say, oh, I know what happens when we're missing a base. That equals log base 10 of 12. And so we can work this out as log of 12 over log of 10. But guys, we already know that we can just plug that into my calculator. That's how our calculator communicates. So we can just plug log base 12 into our calculator. Let's see if my calculator's woken up yet. It has not. And so we're going to just leave it there. We're going to go, that's just going to be log base 12, plug that in, and we're going to get x equals 1.079, rounding that up. Okay. Next up, we have log of base 27 of 3. So once again, we're going to go log of 3 over log of 27. Plug that into our calculator, and we should get 0.3 repeating, or 1/3. Okay? So anyways, that's our first section. Okay? We're going to come back and we're going to talk about natural logs after I fix this calculator. All right, guys. Hope you have a great rest of your day.